Hello and welcome back to the Google APIs for Rust and YouTube Uploader development stream. It's Byron speaking. And we're in the last part of the mission to get YouTube uploads to work because we have to emit null values. And the cool thing is that the null filter is already there, even though I realized there is like no word of documentation. Removes key equal key null tokens. Removes tokens matching. It is kind of optional. Matching this and this. So that's kind of the match statement that we do. Yeah. So this filter null is definitely made in a resilient fashion, which doesn't require a sane input token stream. No, I don't think so. I don't think anything can harm us. Which is very important. All right. I guess I can put this up here as well. Then we have new. Returns a new filter null instance from a token iterator. All right, and the rest is just the next method, the next implementation. Cool, that is that. Now, the difficult part, adapter. We want an adapter that is able to take a token stream and give us a reader interface from which we can read the respective bytes. So the problem is, if you have a look at the token, I might actually want to bring up why am I even trying this? Target doc json index. So we can have it takes a token stream, but the problem is that the token stream here doesn't know anything about the characters that were involved in that. It's just a span that points to the first and end character, a byte in this case. We might also want to adjust the documentation just in case I didn't do it. A pair of indices to the byte stream returned by our source iterator is an exclusive range. Index of the first byte. First byte, last byte. It's all byte based here, but it's okay, you know. Let's see where else we use Unicode or character. Unicode, no. To the source byte stream from the given byte iterator. I was kind of sloppy there when switching from characters to bytes, which up performance by like 30% or so. Yeah, so the problem is we have no idea what these bytes actually are. So we could say, yeah, let's just ignore concerns of performance at all and say we want convenience. So we just drop down some buffer here, some string, and all the bytes we see, it must be a vector. It must be a vector of U8. We don't want to do Unicode parsing. So we drop down a vector here that takes U8, and then we keep all the data. Well, that's all good and fine, but this also means, I mean, it's in fact good and fine. We could do that. This also means we drop all white space, and that we would have to re-add later, like between the tokens. I think JSON wants white space, but I'm not sure. It seems like it. We could easily re-add this. I mean, just dumping dumb spaces everywhere is simply enough for everybody. But yeah, this would solve the problem for sure. But it would also make it so much slower, I guess. Now we cache all the bytes. But at least the bytes are kind of where they belong with the token. We would also lose information about the white space there, unless we have a type white space that we parse instead. So basically, in the case where we parse nothing here, where we just drop it, there we would say, well, it's white space then, huh? So invalid is, you know, setting something invalid is something we would have to do explicitly then, which is fine. We have test cases to verify this is still consistent afterwards. But yeah, we could do it. But we would have to parse white space if you want to maintain white space. So let's have a look at this. That's a typical output from my program here. So what would happen is we would basically just skip that. Sorry, not that. That's true and false. That's actually cool. We would skip this, and the white space would remain untouched. So it's like just erasing individual lines, like with a scalpel. Boom, boom, boom. And in order to like do more, we would have to actually be quite smart if you think about it. So the thing is, if you want to prepare this for user output with the current system that we have, I mean, we have no ast here that we can traverse to just regenerate the white space. No, we don't have that. We are iterating. We are working on lexical level, which means a stream of tokens, and that's it. This kind of makes this thing a bit more complicated, especially if we do not have a token for white space that we could ask for help. I don't think it's a problem, to be honest, because we would have many more tokens like that. So I'd rather drop these. I'd rather drop these. But yeah, there was an email coming in that I kind of read, so now my brain is back, I think. Here we go. Yeah, so I think I want to drop white space, and the cool thing is that we can at least imagine, well, this is not a cool thing. We can imagine white space by the distance between the tokens, right? So we know that this is like 50 and this is 40. So we know that there's like 10 white space between them. But honestly, this will totally be not enough to regenerate tabs and stuff. No. So we could totally drop white space, which would make our system very suitable for sending it to the server, which would solve the original problem that we came to solve, like being able to do a YouTube upload, because we just have to drop null values, and for him it doesn't matter if we just erase individual lines like with the scalpel. That would totally solve the problem. That was the whole idea, right? We wanted to solve this original problem. But I think part of the problem is that I would love to be able to do this as well. And actually I would love to be able to do this. So what about having a simple parser or aster? What about an aster? I don't care about a parser so much because that would verify stuff for us, right? Can we just have an aster? The question is, do we want a verified aster or unverified one? I mean, I would go for an unverified one that just adds white space. Or we do this ourselves. Yeah, what about that? What about the following deal? No matter what happens, we will add our own white space. Because we can regenerate it. I mean, we can generate suitable white space. We don't necessarily regenerate the same one, but we can say, well, after a column, put a space. After a comma, put a space. Simple. After braces, put a space and then a new line, stuff like that. Also with the braces, I would probably also say, well, braces have a new line that follows, or maybe even not. Maybe we want to put it like this, but maybe not. Maybe we want to put it like that. Replicating what they have here. So we regenerate the white space. I think regenerating the white space would be much easier than trying to deal with it. Especially white space. White space is something that is related to the ast here, to the tree-like structure that we have. And this is something we can still easily figure out from the token stream, because we can just count the number of braces we see and the number of, things we see there, and then basically go in and go out. Even without recursion, and I would want to do it non-recursively, because otherwise somebody can feed us a token stream that will make us crash, and I don't like the idea. I don't like the idea at all. Not for a Lexar, not for a system that is that low level in a way. So if we are lexical tools, then we must never crash if somebody feeds us manufactured token streams. All right. So the next, I think that question is answered for me. So I know how to get the white space. Then I will just regenerate it, and then basically I would like to have an adapter that provides the read interface, and then I can throw in a token generator, a token iterator basically, who will yield the tokens that I use to generate the output either with or without white space, like with pretty white space or without. We have options that we let the user pass in. So that's that. I guess here for now, for the filter, you will just say, okay, option is, machine code, so not human readable. This is the option that we use to get this kind of style. And if we don't fully get this kind of style, because it actually wants to have a space here, then we will just, adjust our source string to be suitable for us, and there we go. I think that's something we can do. Well, that about multi-line editing didn't really work out here that well. Okay. Oops. I think that's clear. So the second thing, should we just keep a vector? I mean, okay, let's just do it. Let's just see what happens to performance. I mean, that's what performance tests are there for. Performance drops down not noticeably, it's fine, because the alternative is what? We have, and that's why I did the span thing. We have the original string, right? We have it. And the whole idea is that we look it up, that we look up the things and then just put stuff together. And this is kind of the original intention. But also we are streamable, and in a streaming system, this is far more complex. And I would like to have the ability to stream loads and loads of JSON data, and to stream it, right? And the streaming would still work if you would keep these tokens here. But if you have a source material, then kind of duplicating the data inside of each token is, of course, a total waste of energy, right? And I wanted to not waste energy. Okay, let's see. If this is 10 megabytes slower, then I take it. Let's do it. That's the chars. That's our buff of a U8. There we go. Then we will set it up. I just want that's a peak here. Buff. Default. Well, I think instead of default, I say vec new, which is shorter. Okay, so now we have a buffer, and all I do is, basically I would like to store that character. whenever I don't want to drop it. So I guess I push it on and I pop it here, because that would be easier than kind of adding it everywhere. So self buff push C. And here I realize, oh no, I don't understand this self buff. Go away. Get off me. Yeah, so the minimum capacity for anything for real token. Oh wait, we are in the wrong slot here. Sorry. I put it to the wrong guy. You don't want to have it in the lexer. You want to have it in the token. No. Yeah, we'll make it pub here. Okay. That would be easy then. That would be cool. Why not easy from time to time? The bytes we are representing. And guess what? Well, I don't know. We can still keep the span, but it wouldn't really be necessary. But let's see what the performance says, right? Because it's an iteration-based system, so memory is not an issue here. Even though we will have allocs that way, so we could have a shared buffer to which I mean, there are many possibilities, but I'd kind of prefer to have just this single source, but I don't really know how to get it together in a fully streamed environment where we don't even have that. Then we have to have some sort of buffer that takes the characters, and the span kind of is in an absolute fashion from the first character we ever read to the last one, which is also okay. But it kind of means that yeah, I think we can do this with the duplicating input iterator, like a T iterator that is absolutely there, that keeps stuff for us. And I mean, we can do this definitely. I have ideas. I just want, and then we wouldn't sacrifice anything. But let's see how slow that is. I guess it's like 50 megabytes slower than. Okay, so here we have the token, the buff, and that's not there anymore, sorry. To take away the buffer you just earned, then we need a buffer here. Let mud buff be a vec new U8. Actually, I think I prefer that style. Vec U8. Like this. And then we do the buff push stuff, but only like that. Buff pop. Like that. And last but not least, here we also have a buffer to take care of, which is the buffer that we just maintained. Let me feed it in there. Thanks to move semantics, there is no loss of anything. What do you say, Bencher? It actually compiles. Nice. Ooh. Ouch. All right, there you go. And I tell you, that's not acceptable. It's primarily because of the incredible amount of stuff going on. The incredible amount of vectors. But you know what? There's this vector recycler. On Reddit, which is made for that particular case. You need a lot of vectors. Recycling types with own memory. That's the one. I don't necessarily want to have this dependency or use it right now, unless it's really, really easy. I just want to have a kind of recycled vector thing, but I couldn't really, couldn't really figure it out how I would use it. Because this is kind of much more complex than anything else. Yeah, anyway, so this would be the solution to my problem here. Probably it's a mix of creating lots of vectors and what's the time? 20. Probably it's a mix of creating lots of vectors and pushing lots of characters there, which will reallocate a lot. Let's just for the sake of it, let's just say, well, with capacity, what's the average token? 128. So if we alloc for good, hopefully. This also means we over-allocate, but this should benefit our performance here. And this push of a single character, see, so that's a lot of allocing has been going on, but we are half as fast. We just split our performance in half, and I don't like that. Okay, so the next question, let's stash this away. That's the vec per token. So this is something I've seen coming, and I didn't want that, even though I had no idea how slow it really is. Back to normal, and we're back to like 280 megabyte per second for the Lexer. Good. I mean, there we go. That's expected. That's acceptable. What if we just brute force or forcefully copy the bytes that we see? Because that's something I would consider a possibility. So this works with write, read. So read has this capability built in, which is awesome. T. So I give it a writer, and it will T stuff there. Creates an adapter which will read at, here. Create a reader, partial read, write where errors happen is currently unclear, may change. Well, fine. But something like it will remain, right? So semantics will change. Creates a reader adapter which will write all data into the given output stream. When the returned read instance is read, it will write the data to out. The current semantics, okay. But that's, yeah, the current semantics of this implementation imply that a write error will not report how much data was initially read. Yeah. So the cool thing is we could give it a cursor. So what I'm saying is this bytes thing here, or the null written that's bytes, actually we want a let's have a new benchmark here and use a reader for this. So if we have a cursor, I think cursor bytes, a bridge from implementation of read to an iterator of U8. I see. I want the opposite thing. A cursor, I think, is what I'm looking for. Cursor is a type which wraps a non-IO object to provide a seek implementation. Yeah. So then you can get position, and you have a reader. You have a reader and a writer. Even buff read, because we are buffered. Yeah, cool. So this is like a read-write thing based on an underlying item, which we can provide here. And that's what I would want to do. So let's have it. So throughput in bytes with cursor. Let's see how much slower it is just by using that interface. And just so that we have a comparison. And then we can also add the T thing to have another comparison. And then we have something to work with. Because we must be faster than 50% of the speed, right? If we end up being like half as slow anyway, then all this is like for nothing. Then we can go with the easy implementation. And I really would like to not spend more time on this than necessary, because we can already solve this. Just a question how we are not too bad in solving it. So use std io cursor, and then we have cursor new. So that gives me a new cursor that will allow me to read all the bytes here that I provide. And then I can provide it with bytes again, which then kind of gets cycled back to my original interface. It's kind of a very bad thing to do. Oh, interesting. Cursor doesn't implement bytes. Probably because that would be wasteful or something. But it implements read. I thought read where self is sized. Interesting. Does it mean something goes wrong here and I don't actually... I mean, that's so far, that's good, huh? That's fine. Why can't I put my slice in there and still get a bytes adapter out of there? Where self is sized. But self is sized, isn't it? Huh. That's interesting. Let's play around with it a bit. Do we have read? Doesn't have anything. So it seems. And read it should have. Oh, maybe. Oh yeah, true. I have to use read as well. Now it should have bytes. It appears that a cursor of a... So what is this? This is a... Oh yeah, sure. I have to pass it actual bytes, not a string. Like so. Oh no, that's a bytes adapter. I think I have to pass it as a slice. Like so. No. As bytes. Phew, cool. So now I have it. I think read is also something I don't have to import necessarily. Right? Oh, I do. I definitely do. Cool, so now I should be able to get my bytes back. And now that's basically what I wanted here. So right now we are just pitching and researching, right? In the time we have. Yes, we are. Nothing more happening. So this is kind of a very weird way. I don't know. Probably the as ref would return bytes for me, and as bytes. Well, it didn't complain about as bytes, so I guess that's okay. So if I put it in, it uses it as buffer, it emulates a real iterator, a real read interface, and then we let it emulate bytes again, and that's not even the whole part. So that will definitely slow down our read performance, but let's see how much. So what? Type mismatch. I'm giving it a... But what? Bytes does return... By bytes? Where is it? Does return a bytes iterator. But apparently the result of that is not what I expect here. Ooh, that's terrible. Expected core result. What? Required by JSON Lexo new. Found U8. Ah, now actually I don't get it. Did I find a bug or am I dumb? I think I'm dumb. Something like that. So, it wants to have an item that returns U8. And we have a cursor that has an underlying U8 slice. And we have a bytes adapter that wants to return U8, but it expected a result. And that's weird because we don't return a result here. Never. So it must be something that comes with the bytes implementation that we have here. Well, how do I get it back to my bytes interface, please? Because that's something we will have to do. The whole idea is that I can just take a reader, get a bytes adapter like this. Yeah, can I get an example? Like how easy it is and how they read it. Maybe it returns a result of a byte. Ah, it does. Transforms this read instance to an iterator over its bytes. Its iterator where item is result. See, the yielded item is okay if a byte was successfully read and error otherwise. Yeah. Should I just map this to R and I map this to a, or say unwrap or. Unwrap or. No, wait, I don't want it. Yeah, what can result do? I think, wait, I can do okay. So this will return an optional of our value or nothing, none, and none would natively stop the iteration. And that is kind of what we have to do here. Awesome. Oh no, wait, sorry. We have to unwrap. True, because the iterator interface will deal with the details. Unwrap. But this could fail. I can't just return. Jesus Christ, who wants the result there? Yeah, let's unwrap. But this is dangerous. Can we? I mean, that's a problem I would have anyway. Okay, how can I have an iterator that aborts if the first thing that it gets is... We could filter all the errors. Yeah. Filter map, that's something we could do. Yeah, filter map, that's exactly what we could do. Then we return an option, which is what OK does. Yep. That's exactly what we want. And then we do OK. Boom. Et voila, we kind of skip over everything that has an error unless, or we return it. And there we go. Cool. Look at that. Oh no, wait. 89. Oh my god. That is interesting. We lose a lot of performance here. 90 megabyte per second just for this abstraction. That's crazy. And we didn't even start doing a T here, which we will do now. So with the T, we'll basically store the entire contents in the cursor. So that's this. With cursor and T. That's interesting. Initially, when I was seeing these original values here, I was thinking, wow, it's not a tiny bit faster. It's like as fast. But we're totally wrong. Okay. So how do we do it? That's the original one. Then we put a T in here. Give it another cursor that should keep all the stuff. Let mat keeper be a cursor on a vec u8 new, and this keeper should then be able to store the bytes for us. While we still do what we do, it's just copying them as we go. And at the end, assert equal keeper. Let's see what we have there. I can probably get the original, the inner value again by calling inner. Like into inner. Yeah. Keeper into inner. Lang is null ridden. Lang. That should be the case. Use of move value keeper. Oh, there it moves. Haha, look at that. Interesting. How do I get the thing out of there then? I need to get my cursor back somehow. I need to get it back. Yeah, let's do into inner then, huh? Into inner. Yeah, let's implement into inner in any case. Pub fn into inner takes the self and returns an I. So then we can kind of unfold this thing again and get our stuff out. Self chars. There we go. So we do it into inner, and then we have the cursor, which is a T, which then we then do into inner. So what we get here is a bytes thing. And can all these guys do into inner? How do we get the stuff out of there again? Because they contain something, right? Clone, reverse. See? Inner. Where is it consumed? So I just see where the stuff consumes, where an iterator consumes itself, but I don't see where it kind of gives itself back. It's interesting. How do I get this stuff back? I mean, that's the first problem, huh? Not only that I want to keep track of this, no, but oh man. Yeah. That's certainly no fun. How do I get my stuff back? Because that's a bytes now that I have. With a filter map and stuff, it's super nested. Nastily nested. Can iterators do that? Like unwrap themselves? Doesn't necessarily. I mean, not the trait anyway. But in case of bytes, which consumes it, I might be interested to get these back. But there is nothing. No. Interesting. So that about the simplicity of having an iterator that we use to clone stuff. I mean, that would kind of be the thing, right? That would be our normal reader. And we T some writer, some cursor, for instance, that acts as buffer to just get a copy of all the characters. But we have to pass it in. And it will own everything, so we have to unfold it again. And from this nested iterator, we don't get it out anymore. And we will have at least bytes. And inner probably can't be accessed, or can it? That's different though, huh? Oh, string bytes. Well, they have all different implementations as well. Which kind of makes... No, do they? They shouldn't have to. Yeah, so this is IoT. This is what I want, right? IoT. This returns a T thing that also doesn't support into inner. How do I get it back? I don't know. Which will emit all data to a specified writer as well. But I need my stuff back, man. Can this also be a reference to something? A mutable reference? Can I also do this? Because that would certainly be fine then. Then we take it out. I actually don't. I don't need if I don't know if I need that into inner function then. But maybe I do. Iterate is, yeah, anyway, that's provided. But do I need it? It all works if I am allowed to have this keeper outside and keep it basically. So then we can just have keeper into inner lang, and that should match up. Does it work? Use of unstable feature IO. Ah, cool. Cool, that does work. That's awesome. So that's how that would work. You would not pass ownership. Makes sense. How do they implement this? I usually use borrow mut to have that, but they don't seem to have it. They just need self out W, and W is probably, where is that? That's interesting. FNT. Oh, that needs to be just a writer. And write is also supported for mutables, I suppose, and this is why that works. Without borrow mut. Maybe I don't need borrow mut anymore. I have no idea. Kinda looks like it. And then this T instance. It doesn't do anything special, right? It just knows it has a writer and it uses it as a writer. Awesome. Interesting. I think this changed a lot. This is... I just have to say it needs to be sized, huh? And then this kind of works automatically somehow. All right, there we go. 32 megabyte per second. And if I go down to 32 megabyte per second anyway, then I could also... do I use into inner here? I do. So we want that. Yeah, so can I get my stash back? Let's try. Pop stash. Okay, not onto this one. No. Good. So what if... You know, I don't want to impose this kind of problem onto anybody. What if we say, well, it's something that we provide as a feature, and you may or may not use it. Our tokens now, they are much bigger than before. That's for sure. Which alters performance in any way. But what if we can say whether or not we want to push something? So if... Well, I will completely remove it then. Let's make it for real here. Let's improve this. First, add into inner again, because right now we need it. Oh. Yeah. Boom. Now we'll go down to 280 and probably, I don't know if that affects it even more. 113, yeah, it's kind of halved. That's it. And that isn't affected so much. See this? Because that's slow anyway, that kind of conversion. That's interesting. Look at that. So yeah, I think we can afford it. And I would like to have an if clause here that allows me, or that should allow others to actually own a string to be more efficient. So we can have like different versions of the adapter. We can have an optional buffer that will be used with spans instead to access the slices. Otherwise, the built-in slices will be used. But that really depends on, yeah, something like that. What if we have an enum? Because it's kind of, you either need one or the other. So it's either, yeah, span. Yeah, we could have this could be an enum. I think that's what I want. Okay, so let's see how much, I just want to see how much slower this gets. So if we have, if we can control what we want, what would happen then? I think, yeah, that's what we are doing now. That's kind of, it will be slower at the end, but we will kind of have a nice solution. And I guess that's what we want to do. That's a good timing, because now that I know what I want to do, at the end of the next session, we will have our token information without having degraded the performance so much for all cases, because we will add test cases for all of this. For now, I think I will commit. No, I will not commit this. I will keep implementing this, but I will finish the session. Thanks for watching and have a good day.